In America, sofa manufacturing is a billion-dollar industry. Each year, factories across the country produce over 30 million sofas, supplying homes, hotels, and offices nationwide. Some factories are so large, they can build and ship thousands of units every single day. From massive warehouses filled with lumber and steel to high-tech sewing lines and upholstering stations. Sofa making is a fascinating combination of old-school craftsmanship and modern engineering. Today, we're taking you inside one of America's supergiant sofa factories to reveal how raw wood, steel, foam, and fabric are transformed into one of the most essential and comfortable pieces of furniture ever made. But before we jump in, don't forget to hit like, subscribe, and ring the bell icon so you don't miss more incredible behind-the-scenes stories of how the world's most important products are made. It wasn't until the 19th century Industrial Revolution that sofas began to spread into more middle-class homes. Factories in cities like New York and Boston started producing furniture on a larger scale, using mechanized woodworking tools and sewing machines. By the early 20th century, the sofa had transformed into a central piece of American living rooms. Companies like La-Z-Boy, founded in 1927 in Michigan, revolutionized the industry with recliner technology. After World War II, mass production boomed, and affordable sofas became accessible to millions of American households. In the late 20th century, American furniture hubs developed in North Carolina and Mississippi, where skilled craftsmanship combined with massive factory production. By the 1980s, America was producing tens of millions of sofas annually, serving both domestic and global markets. Today, the sofa is not just a luxury, it's a necessity. Every sofa begins with its skeleton, the frame. Without a strong foundation, a sofa simply won't last. In this giant factory, raw lumber arrives in bulk: oak, maple, and engineered woods chosen for their durability. Massive saws cut the timber into precise shapes, while automated drills carve out joints. These pieces are then assembled by skilled workers and reinforced with steel brackets. For heavier-duty sofas, metal frames are also used. Steel bars are cut, bent, and welded into shape by robotic arms. Once completed, the frames are inspected carefully, because a single weak joint could compromise the whole sofa. Frames then move down a long conveyor system, where they're fitted with support systems. Here, zigzag springs or webbing straps are stretched tightly across the seating area, creating the base that will hold cushions in place. It's remarkable to watch. In just minutes, what was once rough lumber becomes a strong, stable frame ready for the next stage. In the biggest factories, over 5,000 frames are completed every day, each moving swiftly through this highly organized production line. This skeleton, invisible once finished, is what guarantees that a sofa can survive years of sitting, lounging, and even kids jumping around. Factories receive enormous blocks of polyurethane foam, sometimes as tall as a person. These giant blocks are fed into cutting machines that slice them into cushions of precise thickness and shape. Some foams are soft, others are firm. Engineers carefully select the density for different parts of the sofa: a firmer base for support, a softer top layer for comfort. For premium models, memory foam or down-filled cushions are added, giving that luxurious sink-in feeling. Even the armrests and backrests get carefully measured padding. Nothing is random here. Every curve and corner must meet ergonomic standards. After cutting, the foam is wrapped with fiberfill. thin sheets of polyester that smooth out edges and give cushions their rounded shape. Workers then test each seat, pressing down to ensure the bounce and comfort level are just right. In this giant factory, hundreds of thousands of cushions are produced every month. Conveyor belts carry them across vast assembly floors where they are matched to their waiting frames. It's fascinating to think. The exact combination of foam layers, thickness, and fiber wrapping can completely change how a sofa feels. That's why manufacturers spend years perfecting their cushion formulas. Because when you sit down, you instantly know if a sofa feels just right. Massive rolls of fabric, cotton, linen, polyester blends, and even luxurious velvet arrive at the factory in bulk. Each roll is spread out on giant cutting tables where automated laser-guided cutters slice fabric into perfectly measured panels. For leather sofas, large hides are inspected by hand, since natural imperfections must be carefully avoided. In the sewing department, dozens of workers operate heavy-duty machines, stitching panels together into covers. Skilled seamstresses add details like piping, tufting, and zippers. This part of the process feels almost artistic, as raw fabric is transformed into the tailored clothing for a sofa. Meanwhile, another team works with glue guns and staplers to attach fabric or leather directly to the frame. This is called upholstering, and it requires strength and precision. Workers pull fabric tightly, ensuring there are no wrinkles or loose spots. Corners are carefully folded, patterns matched, and seams aligned. Finally, the cushions are stuffed into their covers and placed onto the sofa frame. The transformation is incredible. What once looked like a bare skeleton now resembles the inviting piece of furniture you recognize. The sheer scale is mind-blowing. In super factories, thousands of yards of fabric are cut and stitched every single day. Each sofa might use anywhere from 10 to 20 yards of material, depending on its size. Before leaving the factory, every sofa must pass strict quality checks. Inspectors test the sturdiness of the frame, making sure there are no squeaks or wobbles. They sit and lie down on the cushions to confirm comfort levels. They run their hands along seams, ensuring stitching is tight. Even the color of the fabric is checked under special lights, guaranteeing consistency across batches. For recliners, electrical parts are tested to make sure motors run smoothly. For leather sofas, surfaces are polished and conditioned. Tags and labels are then attached, providing model numbers, material details, and care instructions. Finally, each sofa is wrapped in protective plastic, loaded onto pallets, and sent into massive warehouses. From here, they travel across America, to furniture stores, hotels, and eventually into millions of homes. And there you have it, the incredible journey of how America makes millions of sofas every year. Don't forget to like this video, subscribe to our channel, and hit the bell icon so you won't miss more amazing behind-the-scenes looks into the world's most mind-blowing factories and industries. Magnets are everywhere, inside your headphones, motors, computers, even electric cars. But have you ever wondered how they're made? And what makes neodymium magnets the most powerful in the world? Today, we're diving deep into the incredible science and industrial process behind how magnets are made. From raw elements to the strongest permanent magnets known to humanity. Before we dive into the fascinating world of magnets, take a moment to subscribe to our channel. We bring you deep behind-the-scenes looks at how the world's most amazing things are made. Every single week, hit that subscribe button and turn on the bell icon so you never miss an episode. Now, let's get started. Magnets are materials that produce a magnetic field, a force that can attract or repel certain metals like iron, nickel, and cobalt. There are several types of magnets: temporary, permanent, and electromagnets. But among permanent magnets, one type stands far above the rest in strength and performance: neodymium magnets. They're tiny but mighty, used in everything from wind turbines to hard drives and MRI machines. So what makes them so special? And how are they manufactured? Let's start at the source. Neodymium magnets are made from rare earth elements, mainly neodymium, Nd, iron, Fe, and boron, B. Despite the name, rare earths are fairly abundant in Earth's crust, but mining them is complicated and expensive. The raw neodymium is usually extracted from minerals like monazite and bastnasite, mostly found in China, Australia, and the United States. Once extracted, these elements are purified and transported to specialized magnet factories, where the real magic begins. At the factory, neodymium is combined with iron and boron to create an alloy called NdFeB, the base for high-performance magnets. The mixture is melted in vacuum induction furnaces at over 1,300 degrees Celsius, 2,372 degrees Fahrenheit. This molten metal is then rapidly cooled into thin ribbons through a process called strip casting. This step is critical. It locks the alloy into the right microstructure for high magnetic performance. Next, the brittle metal ribbons are crushed into powder. Ultrafine particles just a few microns wide. This powder is incredibly sensitive to air and moisture, so all handling is done in inert gas chambers to prevent oxidation. The powder is then transferred into a mold, where it's aligned using a strong magnetic field to orient the grains in the same direction. This step determines the direction of magnetism and is essential for maximizing strength. Once aligned, the powder is compressed under several tons of pressure into a solid but fragile compact called a green body. This compact is then heated in a sintering furnace at around 1,080 degrees Celsius, 176 degrees Fahrenheit, causing the particles to fuse into a dense, hard magnet. After sintering, the magnets are cooled and undergo precision grinding to reach their final shape, usually discs, blocks, or rings. But we're not done yet. Neodymium magnets are prone to corrosion, so they're coated with nickel, epoxy, or zinc for protection. The final and most crucial step is magnetization. The magnet is placed inside a pulse magnetizer, a machine that generates a massive electromagnetic field. In an instant, the material becomes a powerful magnet, capable of lifting weights hundreds of times its own. Neodymium magnets are already impressive, but researchers have taken it even further. At the National High Magnetic Field Laboratory in the US, scientists created a hybrid magnet that reached an incredible 45 Teslas of magnetic field strength, making it the most powerful magnet in the world. This hybrid uses both superconducting magnets and resistive magnets in tandem. It's used for cutting-edge research in physics, chemistry, and materials science. In industry, neodymium magnets are essential for high-performance motors, medical equipment, and even space tech. Despite their size, neodymium magnets are not toys. They can snap together with such force that they can break bones or shatter on impact. They're also a serious risk if swallowed, especially for children. In manufacturing, strict safety measures are followed, including magnetic shielding, robotic handling, and controlled storage. As demand for electric vehicles, wind turbines, and high-tech electronics grows, so does the demand for powerful, efficient magnets. But the reliance on rare earth elements raises environmental and geopolitical concerns. That's why researchers are exploring recycling old magnets, developing alternatives, and improving the sustainability of magnet production. The goal: to build a cleaner, greener future, powered by the invisible force of magnetism. These small but mighty components power our modern world, and their story is still being written. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more behind-the-scenes looks at how our world is made. Every single day, trains across the world rely on more than 1.6 million kilometers of railway track. Enough to circle the Earth 40 times, and each mile of that track requires massive steel rails, each weighing over 60 kilograms per meter. That means a single mile of railway line uses nearly 100 tons of solid steel rails. Global demand for rails exceeds 20 million tons every year. And every single rail must be manufactured with extreme precision, able to last decades under the crushing weight of trains that can weigh over 20,000 tons. So how are these supergiant steel rails made? Today, we're uncovering the mind-blowing process of making train rails, the very backbone of modern transportation. The story begins deep underground. The steel for train rails starts as raw materials: iron ore, coal, and limestone. Iron ore is mined from huge open-pit mines in countries like Australia, Brazil, India, and the United States. Coal is baked into coke, a purified form of carbon used to fuel blast furnaces. Limestone is mined to act as a flux, helping remove impurities. Massive haul trucks, some carrying 400 tons in a single load, transport the ore to crushing plants. Conveyor belts move the material for kilometers before it's shipped by train or cargo ship to steel plants. Just think, the largest iron ore mine in Brazil produces over 100 million tons every year, enough to build rails that could wrap around the globe multiple times. At the steel plant, the raw materials face their fiery transformation. The blast furnace, towering over 100 feet tall, is charged with layers of coke, iron ore, and limestone. From the bottom, superheated air at 1,600 degrees Celsius, 2,900 fever, is blasted in at high pressure. Inside, the coke burns, releasing carbon monoxide that strips oxygen from the iron ore, leaving behind molten iron. Impurities float to the top as molten slag, while rivers of glowing liquid iron sink to the bottom. Every few hours, workers tap the furnace, releasing streams of orange-hot iron into giant ladles. Each tap produces 300 tons of molten iron, enough for nearly 3 kilometers of railway track. It's a breathtaking sight. Steelworkers guiding rivers of liquid fire that will one day carry the weight of trains across continents. Molten iron on its own is too brittle. To make train rails, it needs to be converted into special rail-grade steel. Each batch is carefully monitored with sensors and chemical analysis. A rail steel must be strong enough to endure 1.5 billion gross tons of traffic over its lifetime, but flexible enough not to crack under sudden impact. Think about it. Every time a train wheel slams onto a rail joint at 200 kilometers per hour, the steel absorbs forces equivalent to several tons concentrated in a tiny spot. Only perfectly engineered steel can survive this punishment for decades. The purified steel is poured into a continuous casting machine, one of the most mind-blowing technologies in steelmaking. The molten steel enters copper molds cooled by water, solidifying into long rectangular shapes called blooms. These blooms, glowing cherry red, can weigh 10 tons each and stretch 40 feet long. Every bloom is marked with an ID code, linking it back to the batch of steel it came from. That way, if a problem ever appears in a rail years later, engineers can trace it all the way back to the day it was cast.